Yep. All right. Hello, and welcome everyone to AI Camp. And sorry if I'm interrupting your conversations, but we promise you we'll have more time to chat too afterwards. So again, once again, thank you so much for joining AI Camp. And tonight is really exciting to see so many faces. And so thank you for coming. So how many of you, this is your first time here at AI Camp? Yeah, I just like to show of hands. Wow, so quite a lot too. So thank you for coming. How did you find out about us? Just curious too. You just, huh? Oh, Meetup app. Oh, okay, great. Yeah, awesome. Thank you. Yeah, as you know too, there are a couple of AI Meetup groups too in Chicago. And AI Camp is actually, well, I would be showing you quickly too. But as such, we are the Chicago chapter. So thank you for joining us. So, all right. So right now it's just some housekeeping first and introducing the speaker quickly too. So if you can bear with us. So first of all, if you are interested in connected to the Wi-Fi and haven't already found out, that's the Wi-Fi SSID, MSFT guest. And the password, you have to go to event attendee code and enter that string to enter that too. And then also, if you are, well, I'm assuming all of you are registered with AI Camp. So we like you to invite you to also check in with this event. So you can scan the QR code here if you haven't already done so. Or you can go to the, I think there's also another portal, I'm guessing, right, AI Camp. You can do a check-in and give that code over here too. So now if you miss it, you can let me know and I'll share that with you again. So again, some housekeeping. AI Camp, who we are. We're a global AI developers community with 400,000 plus AI developers in 150 plus countries all over the world. We empower every developers to learn and practice AI from anywhere at any time. And there are local community chapters in 50 plus cities and in 15 plus countries. And so in North America, Chicago is one of them here, and we have a really growing community in Chicago. And we also try to build up the Midwest region too. So if you are aware of any other cities that would like to have a chapter, please come talk to us or also talk to the owner of AI Camp, Bill, too. And you can join the Slack channel or the Discord to reach him too. Anyway, so you see that we're in North America, in Europe, APAC, and I guess including, Australia, including, the Pacific region, and also, actually, I think in Africa. I'm not sure if we're in Africa yet, but I believe that Bill would like to also expand this to all over the world. I guess except Antarctica, because nobody really lives there. So anyway, so that's that. Okay, so how to get involved? We invite you to join as community builders team. And if you'd like to speak, you're welcome to submit topics to speak. And you can contact us at this email address, info@aicamp.ai. And you can also, if you're an individual or companies or organization that you would like to sponsor our meetups and also get some raise awareness of your organization, you're welcome to do it anytime. You can sponsor the venues. Like today, for example, Microsoft is sponsoring us, and David too, who is actually, I think he's sitting guarding the door, so please tell him thank you. He's the one that helps us to book this place. And then also, if you want to sponsor food and drinks, and then also prices, at times we'll be running some raffle too. So. Okay, so more learning events. We have virtual seminar weekly, and then also monthly for all the chapters. We will have monthly usually. And then the next one, just want to give you a preview, is that on the 17th of October, we'll have an LLMs night with JP Morgan Chase. And if you're familiar with them, they are in the heart of the downtown loop, I think on Clark Street. Yeah, that's the one. So stay tuned for that. And then there are also AI workshops and boot camps you can join, as well as hackathons too. Okay, so some community shout out. And at this point, if you'd like to make an announcement or tell your story, let's say if you are hiring full-time, part-time, or interns or contractors and all kinds, looking for a partnership, you're welcome to share that with the community. Or if you're looking for jobs, new opportunities, looking for project collaborators or co-founders and hosting events and all kinds of stuff, you're welcome to make an announcement now. Does anybody have anything you want to share? Now, if you don't feel comfortable talking about it now, that's okay. We also will have some time after the meetup. We'll be allowing you to stay and chat too. So, but in the meantime, does anybody want to say something or share your story, or looking for help, or looking for jobs? And no? Yeah, no problem. Yeah, I don't want to pressure you. Oh, okay, you have somebody, okay. Yeah, and I see someone there too, but I'll give first. Oh, okay.
Cool. Hey, my name's John Connor, and I'm a serial entrepreneur, and I've shifted from blockchain, like many people have, to focus on AI over the last couple years. And I started an AI automation agency. It's businessofai.co, and I'm looking to add a senior machine learning expert to the team because we're going to be taking on projects that go beyond my very limited, largely no-code skills. Those are projects we've been taking on so far, but if anyone's interested in collaborating, you can hit me up on LinkedIn, send me a message, or chat with me later today. But just in general, I'm going to be taking on a lot more projects, and I need some more heavy hitters on the actual AI side, technically. Thank you.
Thank you, John. Okay, and we have somebody there, right? Thank you.
My name is Charlie. I'm working on a company called AI. It's a knowledge graph creation studio. So ontology creation, serving knowledge graphs for the purpose of building a fork graph rack. Looking for two things, both engineers, so we're going to hire founding engineers, 3 of us right now, and then also beta testers. If anybody is wanting to test out graph rag or play in the space, we'd love to put you on our beta program. So, yeah.
Okay, great, thank you. Yeah, all right. Okay, anyone else? Oh, good.
Hello everyone, my name is Nitin. I'm also a co-founder. So I'm a product manager at a healthcare company working on GenAI machine learning. So, but that's not what I'm talking about. I'm actually also a non-serial founder, so I haven't actually started a company yet, but super interested in kind of learning technology, work on a few things. I already got a small team of people to start working on things, but would love to connect with like-minded people who are curious about building stuff together, just like casual chats. Yeah, so let me know.
Great, thank you. Okay, great. All right. Anyone else? No? Yeah. Again, no problem. If you can think of something else, towards the end, we can all come together and chat too. Okay, thank you. Thank you for those who shared. Okay, and then here too, there are 2 QR codes if you want to join our Slack channel or the Discord channel. They are here. And if you miss, again, you can come to us and we'll give that to you too. So. And today we want to thank you to all the partners and sponsors. As I mentioned, first of all, Microsoft to allow us to use this venue today. And then also today's sponsored by IBM. The AI Alliance, that's actually is institutionalized within IBM too, and also the Watson X project. And then also the company, I think it's called NIME, am I correct to say it's a silent K, right? Yeah, Corey, right? Yeah, okay, you're right there. Okay, yeah, NIME, okay, thank you too for sponsoring. And then also Equinix too with Logan, so thank you. And then just a word to the company I work for is called Callibrity. I just wanted to kind of bring this up too because it's a consulting firm that's based in Cincinnati. And we're traditionally doing more enterprise type of work, .NET, Java, JavaScript, all kinds, web and mobile, but now we're expanding to AI. So I'm actually heading the AI practice as well. So at some point I may be looking for people too, who knows, right? Or if you're looking for help, wanting to have engineers work for you too, we also have people that we can help you with. So that's that. And so now let's introduce the speakers for today. We have Dean Wampler from IBM, the AI Alliance. He will be speaking, the head of the AI Alliance. And then Corey Weisinger, did I say it correctly? Weisinger, yeah, from NIME. And as well as Logan Chung from Equinix. So thank you. And now we have a word from Ron, because Ron is heading the IBM Center for Advanced Studies in Chicago, right? So. Yeah.
Thanks, Mary. Center for Advanced Studies, we always have this one slide, so you've probably heard about us before if you've been here. Center for Advanced Studies is a branch of IBM, which we reach out to universities and try to work with the universities and see if we can do some research projects with them. So that is our mission, and go and visit the CAS site. It's getting updated. There's some old information in it, and then if we can go to the next slide. Mary? Yes. So all these projects are now, most of the projects that I lead are open source projects. They're all hosted on open development, so you're more than welcome to try it out. Today's live stream is also going to this YouTube channel, which is called Open Development. So please check it out, or if you want to check out the presentations later on, it'll all be posted there. Okay? And these are some of my projects, some of my crazy projects. One is about telescopes, networking of telescopes all across the world. So that's the Cognitive Telescope Network. I'm also working on some algorithms for autonomous cars. So that's the car project. And we do events and stuff and partnerships all over the world. So I have, last semester I had like 100 students with me. So anyways, if you're interested in contributing to any of these projects, let me know. There's of course certificates from IBM to work on these projects. Okay, I think that's it, right? Okay, there you go. Now it's Mary.
Okay. Thank you, Ron. So just again, a quick note I already mentioned about my company, Callibrity. So if you are interested knowing about our company, you can go to the website below, www.callibrity.com. So I think that's all we have. Yes, so at this point, we'd like to welcome our first speaker, Dean Wampler from IBM, the head of the AI Alliance.
Do you want me to stay on mute for the web Zoom call?
Yeah.
Okay.
Yeah, because it's all going to go through the
You may still need to use the microphone for the room,
Okay.
or maybe you're
Yeah,
loud
that's
enough.
fine.
Yeah,
No,
okay.
I'll use it.
Yeah, you use it.
Let's see.
This is
if
still
it
on.
works. Looks like it's working.
Okay.
So we can get rid of this. This is great. Screen sharing has failed to start, but we're all looking at the screen. So let me see if I can just get rid of this. So, there we go. All right.
I still don't have the chair.
You still don't have it. All right, maybe I do have to do this. Try it again.
I think I left my phone.
You want to make
So sorry.
Oh, sure. Let me see, Ron. Let's get out of this. Go back to Zoom. Try sharing again from here. You see what I'm getting? It may be that it doesn't think it has permissions. Let's just try to test. This is the second time today I've had to do this for another app like Firefox. This is like a new Mac, so. All right, I'm going to rejoin Zoom. Sorry about this. Get to read my email, Ron. I'm going to bring this up. There we are. There's a Zoom link. Open. And share. Let's try this again. It's looking better.
That definitely looks better.
All right, are you seeing it now? All right. Woo! Okay. This is going to be so confusing. Which one do I use? This is actually a talk that I gave 2 weeks ago in San Francisco at the AI conference, which is a really good new conference, by the way. Actually, let's see if I can get rid of this. There we go. And it's really about some problems that we software developers are now facing that we didn't have so much before we started using generative AI. And I'll talk about what those are about. But first, let me tell you about the photos. Is this going to work now? It's not going to work. There we go. All right, let's do it this way. Okay, that was what it was. Went too far. So the photos in the background, so here's the thing. I've always put my own photos in my talks, but you know, AI has made photography obsolete, right? So we can't do that anymore. Well, I figured maybe I could compromise and use my photos, but add certain extra elements like this guy right here, if you see the little dinosaur. This is Adobe Firefly. It's actually really good. It really did a great job embedding this dinosaur in the shrubbery here. So anyway. All right, so also I really love this picture on the right. It's a little maybe washed out, but this is not how you build a campfire. This picture is actually fully generated by AI, but the others are actually real photos with embellishments. Okay, enough about that. I want to talk about two topics. So one of them is model alignment, and this is the general process of like taking a model and maybe tuning it on your private data so it's much better at your application. My favorite example is, say you work for United Airlines and you want to train like Meta's Llama to actually be really smart about your reservation system for a chatbot that's going to help customers fix their reservation problems, right? Most likely, generic Llama is not going to be very good at that because it doesn't really understand the idiosyncrasies of the United reservation system. If they can be understood, I've actually tried to use it. But maybe if I train it on everything that's ever happened with that system, all customer interactions, all the data, then I can actually get something that's really good at that purpose. So that's one example of alignment. Other things would be like preventing hate speech, aligning for making it better at instruction following and so forth, but I'll just focus on tuning. But here's the problem. In software development, we like to do things iteratively and incrementally. We don't want to just do like big bang stuff, throw it in and hope it works. I mean, that's the way we actually did software when I started, because I've been doing it too long. But we'd like to be able to do this the same way because that's how we're used to working, but it's actually not so easy. So I'll talk about a way to do it that seems to be promising. And then I'll talk about a harder problem that is not solved, and that is the fact that we as software developers expect our tests to be deterministic. And now we've embedded this thing right in the middle that is completely probabilistic and never deterministic. And what the heck are we supposed to do, right? So let's talk about this. But first, I'll tell you about the AI Alliance. So I'm not actually the leader or director. I report to the director, but I run all the technical initiatives. This is an organization of now over 120 organizations, universities, research institutions, startups, big companies like IBM and Meta are members, all around the world, trying to get a diversity of opinion, but all with the same idea that we would like to do as much in the open as possible so that AI is as widely accessible. Part of it is actually teaching people how to use it, which should come up. There it goes. So with 6 focus areas, one of them is education and then basic research. Also, I actually co-lead this group, Trust and Safety #2, because if you can't trust this stuff, then it's never going to be deployed. So it's kind of a moot point to even do it. Tools for building models and apps and patterns, example patterns. Hardware portability is about, well, NVIDIA GPUs are very, very expensive. Can we not always have to use them? It turns out there are other accelerators, so this is about making sure that it's seamless for you as a developer to use other hardware. Open models and data sets. Mostly what this has been about is like models for molecular discovery so far. We just did a model as an organization for semiconductors, making them smarter about semiconductor technology. And then finally, policy and advocacy is like responding to government requests for, what do you guys think we should regulate, that kind of stuff. So I mostly focus on the middle 4 myself. Okay, let's get back to the talk. Yes, that's a doctored photo, but it's actually based on a real photo from the Oregon coast. Can we actually do model tuning, just focusing on that as a subset of alignment, and actually make it iterative and incremental? And what I mean by this is basically looking at this picture of how we as software developers are used to working. In fact, I actually wanted to start with a little poll. How many of you would say you're a software developer? How many of you were maybe like a ops, DevOps, ML ops kind of person? If you're a ML ops person, how many of you heard this talk last night at the ML ops meetup? I know there was at least a couple of you. Yeah, both times I was filling in for speakers that didn't make it. But anyway, how about like research, kind of academic thing? Okay. And then the rest of you raise your hand, just so no one's left out. Okay. Okay, that's fine. Well, this is mostly kind of, it's especially important for software developers. It's actually kind of important if you're in DevOps. But I think the solutions are going to require research and other things all working together. But anyway, so here's the virtuous cycle of software development, where you decide, all right, I'm going to do a new feature. And the first thing I'm going to do is modify the code so that architecturally it will accept the new feature, but not actually change anything about its behavior. And I'm going to use my tests to verify that I haven't broken anything, that there are no regressions. And then the next thing I'm going to do once I finish that process is write new tests, the lower right, and that will be to test that the new feature works. Well, the feature has not been implemented, so the test will fail, so then I make the test pass, and then I'm done, and that's my virtuous cycle. This is basically test-driven development. How many of you have actually used test-driven development for reals? A few. I recommend all of you try it sometime, because I hear a lot of people say, oh, I don't want to write tests. Oh, man, they're so boring. But actually, once you start using tests first, which is really what it's about, it's actually kind of an amazing revelatory experience. So if you haven't tried it, I recommend you try it sometime, maybe on the next feature you're implementing for whatever it is you're building. But anyway, so a couple of things are nice about this. One is that it's a fairly quick iterative process. I do this on my laptop. And then, I do a pull request that maybe does some additional Git flow validation, building whatever on a server, and maybe at some point I decide when I'm going to do a release. And if I've done a good job with testing so that I really feel confident about my work, I could actually release on every iteration, and that's like living off the head of your Git repo, for example. But anyway, this is our virtuous cycle that we love, but we have a hard time doing it when we're trying to do tuning. So here's what tuning typically looks like. I'm going to start with a base model like, Llama 3.2 or one of the IBM Granite models, or maybe even OpenAI, something like that. Because, this is now the state of the art, right? All of those models are extremely expensive to train, so very few of us should actually do it from scratch. But what we do is we take these models that are generally good over a wide class of problems, and then we're going to tune them. And what we're going to do is we're going to throw a wad of data at it that usually is not very well organized. It's massive. It has everything we want it to know about reservation systems or whatever. And we're going to throw that and then do another training run, really very much like the runs that were done when the model was built, but they're much smaller because the data set's smaller. We're incrementally improving things in a not the way of incrementing that I was just getting at, but anyway, it's not quite as big a process, so it's something that you're more likely to do in your work than like start with creating a base model. But then we've got this problem of how do I actually know the new model is better? And this gets to the second half of the talk too. How do I actually verify that, first, I haven't regressed, like broke old behavior while I was adding new behavior? How do I do that? Well, one of the ideas would be if we could get to a place of doing this iteratively, then if I make small changes to the knowledge that the model has or whatever, then maybe if I notice something goes off, then I can have a much better sense of where things fell apart. Like maybe it was the data set that I just used for that incremental step. So we'd really like to make this iterative and incremental, just like adding a new feature to a web app or something that we're used to, and then maybe have a final server process that does the final acceptance testing or integration testing or whatever. So I'm going to talk about a project that IBM open sourced. Now let me say this. I work for IBM. I'm not an IBM evangelist. I really wouldn't be talking about this if I didn't actually think it was pretty good. So that's my honest confession about this. Now, it's a fairly new project. I wouldn't call it mature, but it's got, I think, a lot of good ideas that help address this problem. And for comparison, actually, there's a Microsoft project called Agent Instruct, which is the other link on there. Okay. So here's the idea. First of all, I mentioned that we kind of don't like this fact that we start with these big wads of data. So can we maybe organize it a little bit better and then be able to incrementally and sort of in a principled way add new data for new knowledge, new behaviors, whatever. And the idea is you start with some sort of taxonomy, and of course we can argue all day about a good taxonomy, but usually if you start with something, it's better than nothing. And so that's how we're going to organize this tuning data that we're going to use. And then if I want to add a new ability, when I was playing with this for the very first time, the model I was using actually sucked at writing haikus. So I decided to add that as a skill, to be able to write haikus. And the way you do it is you would just add something appropriate in the taxonomy, create one of these Q&A YAML files. So the name InstructLab implies that we're really focused on making models better at questions and answers, instructions, following instructions. And then you put in a representative example of just a few examples of what it is that it should be better at doing, whether it's recipes or poetry or logical reasoning or something like that. And of course, we have to use YAML because that's the universal language that nobody can visually parse, but that's what we use. And then here's how we get back to this iterative cycle. So now we're going to actually work on our laptops, and we're going to use this command line tool called iLab that'll let us do this looping process locally and quickly, relatively quickly. One of the things it does is it lets us download a quantized version of whatever the base model is that we're working on. And if you don't know what quantization means, it's like taking a model where all the weights are floating point 16-bit and compressing them to like 4-bit integers or something. So you're obviously going to lose some information when you have something that's that coarse-grained. But it turns out a lot of times they work well enough, especially for this purpose, where it doesn't have to be perfect just yet. And that's something I can reasonably run on a decent, relatively new laptop. And then what we're going to do, I actually probably didn't want to go to this one just yet, but one of the key steps is we're going to use a teacher model to actually generate synthetic data from the example Q&A file. The server-side version of this process actually uses a teacher model also to discriminate between bad examples that were synthesized and good ones. So it tries to throw away things that would, like have nothing to do with poetry or whatever. All right, so we'll run this process with this command line to generate the synthetic data. Then we'll do a local training run, and the technique used is called QLoRa, which is quantized low-rank adaptation. It's a fancy way of just saying that rather than adjust all the parameters of the model, it turns out that one way you can get good results much more efficiently is to actually insert some more layers and just train those layers, a relatively small set. It's a pretty powerful technique, especially for our purposes here. And then you can do things like, all right, you get this new model out, you can run chat with it to see if it's actually just better than the old model at doing poetry or whatever. But it's probably not going to give you terribly great results, not something you would want to ship to production. And that's the purpose is we've used these quantized models so that we can work fast and work on our laptops like we love working, maybe do things incrementally by just adding knowledge a bit at a time. And as long as we're seeing forward progress, it doesn't have to be great, because in fact, we're going to throw away all this synthetic data, we're going to throw away all the models, because when we do a server-side process, the only thing that we actually put in the pull request is just that one Q&A file that we created, and then it basically does the whole thing again on a server with enough resources to use full weight or width models, and then hopefully gets much better results as a result. So now, somebody asked last night when I did this talk, well, it sounds like if you kind of know where you're going to head, why did you do this local process? Why don't you just shove everything up to the server and let it do it? And you might decide that's good enough for your needs. But if you would like to work incrementally, especially if you're a conservative organization about the results and you want to make sure that you really feel comfortable at every step of this knowledge you're adding, this is a nice way to build confidence. Because as we're going to get to in a few minutes, the testing problem is still with us. Because here's the first con, we still don't have much better ways of testing things. We can try it out with the chat feature. They actually use some of the standard benchmarks, so they'll check and see if if you're doing math that it actually gets better on the math benchmarks. But it's a very coarse-grained kind of evaluation, and not at all obvious that it's actually better with this tool. So we still kind of need this real test-driven development process, which I'll come back to. And it's still easy to miss regressions. Like, unless you're really careful in your chat, you should probably go back and check, now did it forget how to write prose when I taught it how to write poetry or something like that? But anyway, I think it's got some advantages. I guess the final step is just practical things that are really unavoidable, like somebody has to do this server-side final training. So your organization's going to have to figure out how to do that, whether you buy time on Amazon or buy GPUs. Now, it turns out the project itself is trying to set up sort of a public build process where people can contribute knowledge in the open, and they'll just keep building better versions of several base models. And then you wouldn't have to worry about it, but you would be contributing your knowledge to the greater good, I guess. But I actually do think that most people will use this tool for private needs, like building a better chatbot at United Airlines and stuff like that, and in which case then they have to have their own infrastructure. And also, even this training process, it's not the full base model training, but it's still heavy enough that you may not actually do it on every pull request. You might batch them up as a practical compromise. And then finally, though, the pros, the reason I'm even talking about this is there's several things I really like about this. One is they've defined some useful conventions for organizing your data. It may not be perfect, it's somewhat ad hoc, but it's better than nothing sort of scenario. And the same with what the command line does. It just hides a lot of the trivial details and complexity that you'd have to kind of decide for yourself and make up for yourself whether it actually made any sense. So that's why I like this tool. It just gets rid of a lot of that stuff. It lets me work locally and incrementally and iteratively. It's not perfect, especially on the testing side, but I think it's a step in the right direction for this problem. Yeah?
The LLM that's generating the training examples, is that also running locally?
Yeah, so the question was, is the LLM that's generating the synthetic data, is it running locally? I think they're actually calling a model on the net. In fact, I tried this on a plane one day and it just would not generate anything because it was not connected. They need something a little smarter than the model that you're running locally. But you could probably jury-rig it to use a local, maybe another model, like if you're using Llama, maybe use Mistral or something just to get some difference of capability. Okay, so any other questions about InstructLab? Yeah.
You were talking about incremental and iterative development. After thinking about the pros of incremental and iterative development, what are the downsides of this development?
Yeah, what are the downsides? I don't think, there really has not been a lot of people who've used this in anger, so to speak, who've actually really used this to develop new models. This came out of IBM's model training team because they started doing this themselves in sort of a very crude way, found that it was an effective way of organizing their own refinement of their base models, and then we kind of packaged it up and open sourced it. So I think the jury's still out if this is going to be really effective for people. I think we'll just have to see. The other thing, too, is I'd love to see us really verify that you can actually tune a model incrementally rather than like in a big bang approach and get equivalently good results. I'm not sure. I haven't seen any research that confirms that actually works, for example. Yeah.
So does this actually help with the hallucinations that we have for the currently existing models? So if we keep on retraining it, this method, trying and giving it more contextualized examples or feeding it the right data, does it alleviate the hallucinations to a certain extent, or is anything being done in that regard?
Yeah, for the video, the question was, does all this help with hallucinations or not? And the answer is no. It's actually just another mechanism of doing the things that we've been doing to kind of mitigate hallucinations. We'll maybe get to this a little bit later, but my personal view is you're never going to deploy a model naked by itself with a chat interface, right? It's always going to be embedded in a RAG system or an agent system where you've got all kinds of things that are bringing sanity checks, bringing like planning or logical reasoning that works or something. So yeah, it's not, this mechanism doesn't really help hallucination. It just maybe makes it a way you could try to attack it, but you'll have to still do a lot of the same stuff. Maybe one last question on this part before I go on? Okay, I'll just go on. All right, so I alluded to this problem of automated testing, which is kind of assumes determinism is really kind of broken now. If we go back to this diagram, maybe you notice that the word test appears in all three of these boxes. I mean, this is, again, if you're used to doing like test-driven development or very heavily test-oriented development, your tests are like your safety guard. They're the things that make sure you don't regress. The things that make you feel confident about refactoring, like improving performance or whatever. And if you don't have those, or you don't trust them because you don't know how to write them, then you're kind of in a problem space, let's put it that way. So what can we do about this? Well, first, just to make it clear what I mean, as a developer, I'm used to the idea that if I call sine of pi, I'm always going to get -1, right? And if suddenly I get something else than -1, I know that I've had a regression. And it's just like a really clear signal, right? No question about it. Yeah, and the idea is that, for a given function, every time I call it with a given input, it'll always give me the same output. Now, this assumes there's no side effects, and any of you that have done functional programming, are probably cringing a little bit, but you know that that's a good principle to have, that sine of pi is always -1. And this, we don't think about it a lot, but this determinism is really the basis for our ability to write tests. If we didn't have this, it would be really tough to ensure correctness and reproducibility and automation to make sure we really catch regressions and so forth. Another way I like to think about this, just a little bit more formally, is that we think about the system invariance. What should be true before and after I make this function call? And how can I check that those things are satisfied every time that I do this? And if I can't define those invariants, it's going to be harder to know that things are really working. Well, we're living in a world now where I call ChatGPT and say, write a poem, and it just returns something different every single time, right? It completely breaks this picture of determinism. And there's this famous not Einstein quote. It was actually Rita Mae Brown, if you know who she was, who actually said this, that insanity is doing the same thing over and over again and expecting different results. But that's the world we live in right now, right? We don't really have that determinism, so we're kind of really struggling to figure out how do we write tests that tell us that we actually got better or worse or regressed or whatever. So what are we going to do about this? Well, actually, put another way, I think it's hard to actually define what the invariants are in a situation like this. You really have to, write a poem. How do I define a test, the invariant for writing a poem? I can check that the haiku format is satisfied, 3, 5, and 3 syllables, but other than that, what can I do? And I certainly can't tell you if it's a good poem or not, but even if it meets the rules. Well, this is kind of a cry for help or intervention, to be honest, because I don't know how to solve this problem. And in fact, I'm hoping that some of you will be inspired to maybe work with me on this, because I think it's a pretty interesting problem. And it's pretty important, or a lot of you will never actually get out of the proof of concept phase into production if you really don't feel comfortable with this stuff. Well, what about our benchmarks? You see those all the time. Probably all of you have looked at leaderboards to see which model is best at math or at swearing or whatever it is you care about. But the problem with benchmarks is they're like too general. They roll up the answer into a single number, and it's not really like a test in the usual sense of sine of pi equals -1. It just doesn't have that precision. Now, it is true, actually, though, if you look at a benchmark, a lot of times it will be something like, let's take a math benchmark. It'll be like a math problem statement and then example answers. And it could be that if you had a way of saying, well, this feature I just added is most like this particular set of data in that benchmark, you could maybe focus in on verifying that those particular data, question-answer pairs are satisfied as you go from one version of the model to another. So I've been thinking a little bit about that. Like, do we just need to peel the onion a little bit and see what's going on? Now, those of you who know what RAG is, Retrieval Augmented Generation, it already has a tool we can use for this, and that is, how do I know which of those question-answer pairs are most similar to the thing that I need to verify? And RAG is about a similarity metric that is against an encoding, so that when you ask for a poem, it can find whatever data it has in its database that's most relevant to writing poetry, and then feed that as part of the context that goes to the model. So something like that might help. The other thing that could help possibly is just much more specific benchmarks that are focused on a very different, very specific problem, like maybe benchmarks that really hone in on the things that a chatbot for United Airlines needs to do, something like that. Now, another idea that is actually used already for other purposes is having a critic model that looks at the result and says that's good or that's bad. And this is actually turning out to be the way that most people are probably in the future going to use really big models like OpenAI and Llama 405B and those kind of things that are kind of too expensive to run most of the time, but are actually more powerful than they need to be for like typical use. But they could be really good in your test regime telling you whether this model has actually gotten better at running a set of queries. And so, in fact, we're already doing this. I mentioned, in fact, that InstructLab uses a smart teacher model, really a critic model in this case, to filter out bad examples that were generated by the synthetic data process. So you could maybe think about applying a similar metric to being more critical of the results that come out after, when you're running something that looks like a unit test anyway. And the last thing I'll say about this is really the last slide, is can data science help? So, this is all statistical, the results, it's all probabilistic. Are there ways that we can kind of constrain the problem? You data scientists, this is really a call for you here in the room, to actually give us a sense of when things are within reasonable bounds or not. I actually started life as a physicist, well, not life, but started my career as a physicist. And one of the big things in like experimental physics is so-called 5 sigma, is a term you'll hear, which means if you see a signal for what might be a new elementary particle, it needs to be 5 standard deviations away from whatever mean or norm that you have to really believe that it's actually a valid signal. And when you get 5 sigma, then you actually declare you have a discovery, is sort of the idea. So we need something like that here. Now, I'll just mention a few other things I don't have on slides, and that is, I sort of alluded to this early, just don't put these models out in front of your customers bare, without anything else that helps them be smarter, that helps constrain the results, that checks the results, checks the queries, that they're not trying to game your system or whatever. I think these are all things that we're just going to have to get smart at doing so that we just raise our confidence until we can get to the point of really believing we have something reproducible. Was there a question back there? Or? Maybe not. Okay. Well, so I'd love to hear your ideas about this problem, what you think we should do. And my contact information is on this slide. Can you see the dinosaur in this one, by the way? So anyway, feel free to reach out to me at this address and check out the AI Alliance. I'd love to talk to any of you about that. You can get this slide deck with this whatever product code. Yeah.
I have a question about can you go a couple of slides back?
Sure.
About using the teacher model to predict. Yeah, so basically, I would like red teaming the test model using another LLM at this point. How we make sure, or like how we quantify that the test model, the predict model is good enough to discard some potential bad things.
Yeah, the question was for the video, how do I know the critic model or discriminator model is actually good too? So you're going to have to figure out some way to satisfy yourself. Actually, people raise this question about tests. Do I need tests for my tests? And usually the answer was, well, they kind of are self-reinforcing the test in the code. So there may be ways that you can just verify to your satisfaction that the critic model is pretty good, but I just wouldn't assume that it is. By the way, somebody mentioned last night when we were talking about this, the idea of like bringing GANs back, generative adversarial networks, where you actually really focus on giving it bad examples with poor scores and then try to get it to be very good at discriminating bad results. So that could actually be very profitable. Any final questions on this stuff? Let me get to the end. There we go. All right, thanks so much. Oh, wait, there was a question here.
The question is that if you're already relying on supposedly machine critic model to rate our example
you're already, the point that you're already reliant on a model or on a group of experts model that is going to everything work for you. So why not use the same model or the same family of models to do it?
Yeah, so let me paraphrase the question for the recording. Why not just use the smart model that you're using as a critic? Why are we doing all this stuff with these dumb models? And the answer really is cost. These bigger models are much more expensive to run, and the trend now is actually towards much smaller models. Actually, if you read details about Meta's announcement of Llama 3.2 this week, they released like a 1 billion and a 3 billion parameter model. They're not going to do great on benchmarks, but they're actually small enough you can run them on a phone, for example. So that's really where it comes, why you would have this sort of dichotomy between not just for using the smart model all the time, it's really cost is what it comes down to, and the footprint that you can run on. Yeah, question?
Do we have a metric to test the feature model or so do we have a metric to test the feature model on how it performs? If we are relying on a certain model to test the efficacy of the current model we are training, so the model that we train will only be as effective as the model that tests it. So do we have a metric for that, and how, if we have a metric, how we are able to test it?
Yeah, the question is, do we have a metric for this teacher model? Again, how do we know it's good? And the answer is, we kind of don't unless we trust benchmarks. So you might decide, okay, I do trust the benchmarks. Like, let's say Llama 405B, hits 99% on some math benchmark, but I need a model that can do math and fit on a phone. Then I could use Llama as the teacher, Llama 405B, while I try to improve that small model until it's good enough to run on my phone. So that's sort of it gets back to that philosophy of what's the smallest thing that will work, and I'll use something smart but expensive to train it, and then send it out in the world, sort of. I should probably stop, but I'm happy to take questions afterwards, so thanks so much.
Yeah, it goes outside, yeah. Only this one, yeah. Okay, hello. Okay, so that's good. Thank you so much to Dean. And then if there are more questions, I think, Dean, you'll still be around afterwards, right? Yeah, so we can have more conversations afterwards too. So thank you for all the good questions. And now we'll have Corey from NIME to do your presentation. So thank you. These works if you prefer the lapel.
Oh, this is okay.
It's okay.
There we go. All right, thank you. Yeah, so today I'm going to be talking a little bit about the RAG models that we've kind of touched on a little bit in the first presentation here. And I'm going to talk to you a little bit about the company that I work for called NIME, as well as how we implement some AI solutions with our own software. Okay, so before I get to that, maybe I should also introduce myself. My name is Corey Wiesinger. I work as a data science team lead at NIME. Traditionally, I work on forecasting applications, but I think at this point, all of us in data science are working at least in some capacity with AI models. So my agenda for today is to give you an overview of how AI in NIME works and talk to you a little bit about how we're using a RAG model to help us generate content for social media. So let's just jump right into that. At the end of the day, I just want to give you a little bit of extra vocabulary to talk about RAG models, to talk about embedding models, and some vector store stuff, and go from there. So my first section is AI in NIME. So when we talk about using Gen AI inside of the NIME Analytics platform, which is a low-code software, it's a visual programming language that's open source, free to use, and probably really familiar at this point since there's so many similar products on the market. But we see three different kind of categories of Gen AI usage. The one on the left here is assist and explain. So this is where we have things like Copilot, where you might have a AI embedded in your code editor to assist with writing your own programming, and things like helping you build your own workflows as well. So that'll be something I'll show you in a little bit here. The other side is use and customize. So this is where we want to be able to actually use custom AI solutions where we'll be able to connect to things like OpenAI, connect to whatever LLM you want, really. We have integrations with GPT for all, as well as Hugging Face. So there's really a lot of ways that we support connecting to LLM models. And then the final category down here, oops, I'm losing my slides, is on managing and governing. So this topic I'm not going to hit on too much, but I wanted to include it in my slides anyway. So again, these are the kind of the ways that we see these types of usage of AI. So conversational search, so maybe you're looking for a tool or a function in a package that you use and you want to be able to find it, but you don't know exactly what you're looking for, so Control F doesn't work, maybe Googling it's not working, so you really need something that gives you context. So this is where some of this RAG stuff is going to come in. How can we use chat models that have context? The other part here with this use and customize is kind of building these tailored solutions. So these are the connections that we see there with OpenAI, with in-house AIs, and these different connectors. So this is a little bit of what the AI assistant looks like in KNIME. So this is, of course, a screenshot of the application on the right. So it's a drag and drop tool where you have these blocks that build out a data pipeline. So you have some readers on the side here, but what I really want you to see is on the left, this incorporation of an AI assistant directly into it. So this is one way that we include AI in our software. That exists as well in our integrations for coding. So that's stuff like Python, eCharts, R, etc. Okay. Now, the actual extension that we're going to talk about today a little bit is called the KNIME AI extension. You can see some of these tools on the side here on the left. So these are opportunities to connect and authenticate with OpenAI, so you can log in, you can connect to the different GPT models, and build some of these RAG solutions that we're going to talk about in the use case. Okay. So we've got, like I said, these authenticators here. It is a little bit bigger for you. LLM connectors, chat model connectors, agent methods, and things like this. So the use case that I'm going to walk through with you today is using KNIME and using our AI integrations, but it's for AI video script generation. In just a second, let me fix my PowerPoint. I think it's on a slideshow. We'll just work with it. So this is our KNIME TV YouTube channel. So we've got a lot of YouTube videos up here. We also are active on Instagram and TikTok, trying to promote our company, trying to be more engaged in these different areas. But we're all data scientists. We're not necessarily social media influencers. We don't put together new videos in 30 seconds. We usually have to write scripts. We usually have to prepare for them. And most of us aren't native English speakers either. So this is also a great reason why we put together scripts for our videos. And this takes a long time. So when we're talking about generating new social media content, we sit down, we write some scripts, maybe we go through and record some audio and do all these other steps. But the part that really takes us the longest is writing the scripts. And sometimes a lot of these ideas come from our marketing team. And maybe they have an idea for a video that they want us to create on random forest, let's say, for example. But the marketing team doesn't have the experience to write those scripts for us, so we have to do that part ourselves, and we're not the fastest. So this is where we decided to try to implement some of our own AI solutions to help ourselves internally with this script generation. So I can't go straight to ChatGPT and say, hey, I need a script for a KNIME social media video that talks about decision trees. It won't really have the context that I need to create that script. So what we decided to do was use the RAG framework. So this is retrieval augmented generation. So the idea here is that we have a knowledge base that is all of our NIME content that can be used by the AI to give better context to its responses to our prompts, asking it for things like video scripts. So the goal here is just to give it better context in its responses, have an LLM that's more knowledgeable, and kind of reduce these risks of hallucinations. Because if you go straight to ChatGPT, you're finding things like made-up nodes, tools that don't exist, references to people who aren't real, and things like that, because we're not that big. So we wanted to give this user-curated, domain-relevant knowledge. So that's really what we wanted to do. So that's kind of the purpose of a RAG model. So there's 3 steps to it, right? Retrieving the relevant information, taking this relevant information that we retrieve from this knowledge base, whatever that happens to be, and augmenting the prompt. So this kind of comes back into prompt engineering at its core. I say, hey, I need a script for this video. We go to the knowledge base. We search for things that are similar to decision tree. Maybe it pulls back some documentation on our decision tree nodes, or maybe it comes back to a blog we've written or a script we've generated, things like this. And it uses that in the prompt to generate a better response. So this is a little bit of what it looks like. So maybe I say to the model, who won the soccer World Cup? If the soccer World Cup happened 30 minutes ago, it might not know yet. So this is a pretty big question. You might get a good answer from ChatGPT. But the idea is that this question can first go to my knowledge base. So this little database diagram up top. Some relevant information comes back down, augments my question, and then the AI uses the knowledge received as well as my question to generate this response that says, Argentina won the World Cup. But how does that work? So that's when I want to talk a little bit about embedding models and vector stores. So this is kind of the core of building a RAG model. So an embeddings model has been around for a while. You might remember autoencoders or these different image or data compression algorithms that came out years ago now. But ultimately what we're doing here is we're taking some input, in this case it's text, it's also common with images or just any data type really, and we are reducing it into a vector representation. So here's a dummy example really, where we say the text at the input is the Oscar for Best Actress goes to, and then the embedding model happens and we get out a 5, 7, -2, 3 vector. So this is going to be a lot bigger vector. It's going to be a lot more interesting than this little block for an embedding model. And it's going to be a lot more complicated than a traditional autoencoder, as modern embedding models are going to use things like transformers and stuff that we won't get into too much right now. But here's the idea. So we have 2 different inputs that get placed into these vector embeddings. So maybe I have these 2 different ones. They're not too similar, so the vectors are pretty far apart. Now, if I put a bunch of different documents in here or a bunch of different things that I want to be able to reference in my knowledge base later, they get these different vector embeddings. And one of the things that was brought up earlier was using this similarity, which is what we're going to look at here in a second. So you can see that down here, these 2 are very close together. This is about a football team in Germany as well as this one. So maybe that makes sense that they are embedded very close together. And modern embedding models use a lot of context. They're trained models. They have a lot of transformers and knowledge in them that enables them to use some exterior context, unlike autoencoders of the past. So we see a lot better results out of this. Now, the reason we wanted to build this vector store was so that we would have a knowledge base that was retrievable with questions. So the idea here then is my question can come down. Let me move this out of the way a little bit. Who won the Soccer World Cup? And that gets embedded as well. So this comes in, and now it's placed in my vector embedding as well. And the idea is that I can look for distance measures that are close to this new embedding of my question. And those vectors that are close, here with this gray circle, are relevant bits of information. So we see 3 kind of drawn inside of that gray circle. Those happen to all 3 be football references. The closest one is probably the best one here, luckily. is referencing the World Cup in particular. So this is one way that we can use vector embeddings as a way to take knowledge and search for it later with our questions. So the real reason we're doing this isn't for any kind of reduction in data size here. It's just so that we have this ability to do this similarity search. So we've embedded our question, and we're looking for documents in our knowledge base that are similar. Okay. So now I want to show you a little bit of what this looks like in the NIME Analytics platform. So on the top left, you see that we're connecting to OpenAI. So that was the first thing. In this use case, I'm using ChatGPT. So I've connected to OpenAI up here in the top left. I've also connected to an LLM. I believe I was using 3.5 Turbo in here. And then we also have this second line down through the middle. And this is where I'm talking about creating the knowledge base. So I'm just going to use the OpenAI embeddings connector, so I can use their model, a lot more advanced than one that I build myself. I'm using the vector store creator and that embeddings model to take some PDF documentation that I have and embed it into this vector store. And it's really just as simple as that, to create a vector store of knowledge and use it in an LLM prompter in NIME. So really, I'm leveraging all of these solutions from OpenAI in this visual tool. Down here, I'm just using a string manipulation to kind of combine those relevant documents that were sourced by my vector store retriever, as well as my prompt to pass to the LLM. So here we have the embeddings model, then creating the vector store with the embeddings model, and our question, retrieving it. But we can go a little bit further than that. So that's kind of the first step when you're trying to incorporate a knowledge base into an LLM. But a RAG is cool, but it's not necessarily the most intelligent. So the next thing that comes up after that is a conversation about using AI agents. So AI agents are basically a way that you can use all of these tools like a vector store without doing it in a hard-coded way. So you remember looking back at here, if I look at this workflow one more time, I'm doing everything the same way each time. I'm saying, okay, here's my question, give me the relevant document, put that relevant document into the prompt directly and send it to the AI. But with an AI agent, we can do this a little bit differently, and that's what I'm going to talk about next. So conversational retrieval agents are a way to let the AI, the chat model in this case, decide on its own if it needs to reach out to a tool that it's been given. So in this case, I'm going to instead take my vector store and convert it into an AI tool. So this is a feature from OpenAI's integration, and allow the model to decide on its own if it needs extra context to answer the question that I'm asking. And if it does, it can go out and use that vector store to retrieve it. So this is a little bit of a diagram of what an agent like this is doing. So I prompt my AI. I say, hey, I need a script for a decision tree video that I want to put on YouTube. And it says, do I need a tool? And then it does, because it doesn't know anything about the NIME decision tree node. So it goes to my vector store, it looks up decision tree in the vector store, it finds a few relevant blogs, maybe I wrote about a decision tree in the past, maybe it found our documentation describing how to build a decision tree in NIME, and it pulls back that context and uses it of its own volition before it answers me. And you can do this with multiple tools or just the one like I'm using here. So these are the relevant nodes that I want to talk about when it comes to swapping from just using a vector store to using a vector store as an AI tool. So I've created the vector store. I just used that embedding model from OpenAI to create it, and now I just use this vector store to tool. And this is really just a change in expression. It's still just a vector store. It's still just going to be doing this similarity search based on my prompt, but the AI gets to decide on its own when to call out to this and retrieve that additional context. Okay. So, look at a few more here. So the first thing that I'm doing here, again, is this swap from just using a chat prompter to an agent prompter. So this is the type of AI that I want to use here so that it can reference the tools. So instead of using this other node that I showed you in the past, go back a little bit. That was more than I thought. I was using just a prompter. So I just passed a string value in, it goes to the OpenAI model, and it comes back as a response. But now I'm going to use this agent prompter instead, which has a few additional inputs. So I'm not talking too much about NIME here, but think of these left blocks on this left sides of these nodes as inputs to your function, whereas the ones on the right are outputs. So now I'm providing it with a prompt as well as references to tools. Right. So I'm converting my vector store to a tool and passing it to this agent prompter down here instead of just the chat prompter. So I've created my vector store, I've converted it to a tool that can be referenced by my agent prompter, and I'm saving my conversation history. So this was an upgrade for us on top of just using a RAG model when we're trying to get these script generations, because it allows us to go back and say, hey, I don't like this script, can you change the tone? Can you make it more friendly? Can you make it more exciting for TikTok? And things like this. So this was really a big deal for us to be able to go back and change it into a chat model that could repetitively reference our vector store. And this is a little bit of what it looks like to work with on the side. So when I'm configuring this agent prompter, I can suggest these different roles for it, as well as give it some information about the tools that are presented. Okay. So the steps that we had to go through to do this were collect data representing the knowledge base. So to do this, we parsed our own website to scrape some of our blogs. We pulled down our documents on our document section, and we pulled all of the node descriptions from inside of the application and pooled them together into a big table. So now we have these different records in rows representing different sources of knowledge, and we use that embedding to build that vector store. So I'm going to show you a little bit of how we did that in particular. So this is the actual workflow that we're using to help us generate video scripts. And we're connecting like you've seen before. I have my different data sources being concatenated down here at the bottom, coming in and collecting all of the knowledge that I want to use for that knowledge base. I've connected to OpenAI for multiple reasons here. I've got the chat model up top after authenticating, as well as this embeddings connector. This embeddings connector is what I'm using to create the vector store based on my parsed data from our own website. And then that vector store is being converted into a tool that the agent creator will reference. So we see that over here with the agent being created and the vector store being converted to a tool. Okay. So then moving on to the final bit of the workflow, we have the agent created. We've converted that vector store into a tool, and now we have this chat model at the end. So I want to, oops. I may have lost a slide. Okay, we'll come back to that. So after I've assembled my knowledge base and created my agent, so this is just some moving of pieces around, I need to do my prompt engineering. So there's a couple different parts of engineering the prompt. There's this first thing here called the system message. So this is just the kind of baseline information that I'm giving to my model all the time. So this gives it context for why I'm talking to it. And what we wanted to do here was make sure that it knew it was generating short scripts. So if I go in and say, hey, I need something for geospatial analysis, it will come back and say, already knowing that it is a computer model that is designed to generate short video scripts for YouTube, TikTok, Instagram, and that when it gives me the format response, it needs to do that with references to who's speaking, maybe some scene change information, kind of generating a screenplay, really. Okay. Right. So this is kind of going back to that workflow one more time, where we're talking about how to do that prompt engineering. So I'm not actually showing the prompt engineering here This gray box on the right is an encapsulation of some of the just string manipulation stuff that we're doing at the end to kind of combine things together and make a little pretty view. But this is what it looks like when we actually run the application. So I can go in there and say, I want something with geospatial analysis with KNIME video script, and it will respond with this. So it starts off with the narrator saying, hey, welcome to our presentation, and it goes on to reference specific nodes and by naming our geospatial processing extension correctly. So incorporating this RAG model into the desire to accelerate our script writing process has really allowed us to reference very specific things and tune some of the output that we get there. And converting it into an agent in a chat model here at the end has allowed us to tune this. So this is not the final script that we've used. We've done some editing, said, hey, I want the tone changed. It needs to be a little bit shorter, and things like that. So it allows us to give feedback actively with a chat model instead. Now, this is the final output after a few exchanges of dialogue there. And one of the things we wanted to do was actually use a text-to-speech tool to kind of create a fully automated topic to video pipeline. But our marketing department says that real voices are better. So I won't play the text-to-speech voice. I'll just read some of this script for you. So it started with, hello and welcome. Today we're diving into the fascinating world of geospatial analytics, a powerful tool for organizations worldwide. Just imagine being able to analyze and visualize location-based data to uncover valuable insights and make informed decisions. At the recent KNIME Fall Summit 2022, Professor Wendy Guan from Harvard's CGA team showcased the importance of geospatial data and the challenges of accessing and analyzing it. So that's kind of where it starts, and I think this was a really cool example of why RAG models are so important, and they're honestly so easy to use too. Because this reference to Professor Wendy Guan, who spoke at our Fall Summit in 2022, is a really specific reference that you wouldn't get in a general usage AI. So RAG models are a really great and really important way to tune your model to a specific use case like this one. And with KNIME Analytics Platform and this framework that we provide here, it is very easy to do this quite quickly. So again, this was an open source application where you can play around with these AI agents really easily. Is that a question?
What if your model's already been trained and Wendy Guan was speaking in 2021, and then now you did this RAG prompt augmentation, and there was a conflicting piece of data in your prompt, how would it know which one to choose?
Yeah, so the question was, if I had done this before 2022, for example, before Wendy Guan spoke, how would it know what one to choose? So one of the nice things about using a RAG model as opposed to using a fine-tuning process is that I can update very easily my knowledge base. So if I have incorrect information in my knowledge base, then I'm going to get incorrect information in my responses. And that's always going to be a problem with RAG models, but it's much easier to update my knowledge base and maintain that knowledge base than it is to retrain a model on fresh data so that it has a fresh set of knowledge internally. I don't know if that answers your question or not.
Choose the prompt information over the model.
Oh, okay, I see. So if I had said in my prompt something else that contradicted the knowledge base, that's a good question. I assume this is something we could tune with some of the temperature settings that are available in the agent prompt or in the tool settings. But yeah, so this one probably found, this is a reference to a blog about Wendy Guan, this 2022 Harvard speaking at the summit reference. And now if I had said something like, is there a question?
Yeah, so a comment basically. So if you're actually doing RAG, you're retrieving the information from your vector database and then prompting with that to get the answer over here. So in that case, you will not be sending a wrong prompt because you're finding the right answer from your vector database, right?
Yeah, so the comment was that with the RAG model, the correct information from the database would be included in the prompt. And that's true, but so this is kind of a question of if I have 2 bits of information in the same prompt, if I say in my actual text that I send to the agent personally that I wanted to reference Wendy Guan from 2023, but it finds 2022 in the knowledge base. I'm not sure which one it would use. That'll probably be part of the non-deterministic thing here, where it's got 2 bits of information in the prompt and it has to pick the one at some point.
Usually you'll do a case search or something, right?
Yeah, so
In that case, you'll find one of them. One possibility there is that the similarity search would not do the.
yeah, so the comment from over there was that it might not even find the correct document if I say something incorrect. It might map my request to a different part of my vector store. But in general, when we're trying to use these, what we've been trying to do is we've been trying to keep our prompts as simple as possible and as short and direct. That way, when I put it in there, it's got the best chances of finding correct, similar documents in that vector store. So I try not to get it too convoluted. Otherwise, I might find that it picks up on just the words that I'm using, or if I talk too much about Wendy Guan, it might talk about something else she's done. But I really wanted to pick up on just geospatial analysis. So this is part of the prompt engineering process where we have to decide how best to interact with these and how best to send our prompts. And this is also true with some of that system message stuff, which isn't going to go to the RAG model portion, but I need to be careful about what I put in there too, so that it doesn't overpower the rest of what I've been doing. Okay. Another question on that part? Yes.
When you did the retrieval part, did you guys do any optimizations to run it faster so that it retrieves the information faster from? Because in the end, you're still doing a sense of that.
Yes. So we haven't done any optimization on that in this case. Our vector store for this use case is quite small. It's comprised of a few hundred blogs, a few hundred pages of documentation, or probably a couple thousand documentation pages, but it's still relatively speaking small. So we've not had too much trouble with that. Yeah, so we haven't done any optimization on the vector store search. Question?
So this 9 application, so what's the source code was used to create this application?
Yeah, so that was a little bit of a question about the KNIME software. So KNIME Analytics Platform is open source. You can find it on GitHub, but it is a Java-based application. So some of our extensions are coded in Python, but the core of KNIME Analytics Platform, which you've seen a few screenshots of through this talk, are coded in Java.
So if someone is expert on Java, they can do totally use Java to replicate everything you did in KNIME. Would it get the same result? Would it do this?
In this case, probably so, because all of the tools that we're really deploying here are integrations with OpenAI. So I'm reaching out to ChatGPT 3.5 via KNIME, via Java, and using their results there. So, yeah.
The RAG pipeline, I can see that we're using OpenAI. So what do you think, because OpenAI API always intercasts, so what do you think the work that you need to put in to replace it with open source model like Llama?
Yeah, so the question was, in this use case, ChatGPT is not a free-to-use model. So how much work would there be to replace it with a different open source model? So I'm trying to find a good screenshot here that shows everything. Here we go. So this was the full workflow in KNIME Analytics Platform, from extracting our information, creating the vector store, and creating the chat app. And in the upper middle portion, you see where we're using our OpenAI authentication and then connecting to an OpenAI chat model. So we support connections with a variety of different chat models. So this is the part of the workflow that would change. You would, instead of connecting to OpenAI, you might use our Hugging Face connector or our GPT for All connector to connect to a different model, and then go, the rest of the pipeline would stay largely the same. Yep. Question?
So with RAG and the agent model, I guess you all have moved to the agent model later on. First you implemented the RAG and then moved to the. So how has the results altered or output, has it like enhanced? What's your experience on it? And do you think it's a like a good approach rather than like creating more prompts or like better prompts to actually get to the results through a RAG architecture instead of making agents? How does that approach fit?
Yeah, so the question was, if I can paraphrase a little bit, why did we swap to an AI agent over just the RAG model, and did we see any improvements? So we started off with just the RAG model, and we really just used that one for a day or so, and decided that we were going to swap to an agent, which wasn't a big change, as you can see. It's just a couple nodes being moved around in the workflow. But the reason we ultimately did it was because we wanted to have the ability to go back and kind of give it feedback when it gives us a script. And sometimes it would give a bad script, and I could say, no, that's not the right topic. You're talking about this. I really want you to talk about geospatial analysis. And it would still have the ability to go in and go back to the tool and retrieve new information from the vector store. So that was one of the upgrades that we saw from swapping to the agent, is that it could multiple times go back to this vector store, but it wouldn't have to. Yeah.
So the conversation agent that you have, does it autonomously decide what tool to use, or do you tell it?
Yes, so in this case, there's only one tool being plugged into it. And let me see if I have a screenshot of that. So it will autonomously decide whether or not it needs to use that tool. So the idea with this one is we tell it it's a knowledge base, and it will search that for information if it doesn't feel like it has enough context. So that's the idea. Okay. Any more questions before I get to the wrap-up? Sure.
So clearly this is a slightly more advanced model that you've seen. How well are companies adapting and adopting your model as opposed to the old school RAG model?
Yeah, so in this case, just to be clear.
What challenges you're facing in that?
Yeah, so maybe I can talk a little bit about how we're handling that internally, because we're not OpenAI, we're not producing the model in question here, the LLM in question. We're just accessing it through our own software. And this is one of the reasons why it's so important that it's easy to change which model you're connecting to. So back here again, you see that I'm using OpenAI, but I can swap it to Hugging Face, or I can swap it to Gemini very easily. At NIME, we've got a small legal team, and they have read through the terms of use of OpenAI's models, but not through everyone else's. So internally, we just use ChatGPT, because that's the one that our legal team has proofread, right? So that's kind of where we're at with OpenAI. We're using it because our legal team has verified it. And if we explore some other ones and we really want to deploy a different one, then we've got to go to our legal team, make the case, and go through that. So that's kind of how we've lived the experience of picking AI models, is getting sign-off from our legal team. Yep. Okay, I'm going to continue to that wrap-up then. Okay, so now just a chance to summarize a little bit of what we talked about. So I wanted to show you today the AI integration with NIME. So that was all of those tools in, again, this open source visual programming language that allow you to connect to things like OpenAI, which is what we showed today. And now I'm still moving. Talked a little bit about what a vector store is and how they're created with embedding models, and how that ties back into the usage of LLMs and AI with RAG models. And then the advantages of using an AI agent to use this vector store, this knowledge base, as a tool that the LLM can choose to access when it doesn't have enough context. And then finally, just a little bit about how we put that all together in a chatbot to be able to interact with it and kind of tune the results it gives us in real time. If you want to do any more reading on LLM solutions in our software, then these are just a few blogs you can check out talking about how to mitigate hallucinations, how to build your own LLM solutions, and a few other topics like that. So maybe just a little bit of what we're going to do next with this. So we've had pretty good success with this. We're pretty happy with how it's accelerated our writing pipeline. And we kind of want to use it in a few other cases. So we want to use it to check for tone in things like new blogs or in technical documentation to align with our marketing standards. We want to try to use it for generating outlines on blog writing if you want to do, and things like this. So really, we're just trying to find ways that we can use models of a similar framework and embed it directly into existing processes. So some of the new things we want to explore is we're also exploring some ways we can use models like this for translation. We're already using a model like this to translate our PowerPoint slides that we share in multiple languages, so that like if you wanted these slides in German, we have a translator app for that we built. And we do that ourselves because we're very much a global company. We've got people all over the US and lots of people in Germany. And we really present all over the place in all different languages. And it's very helpful for us to be able to automatically tune our slides and keep them all up to date. So these are just different ways that we're playing with our own software internally at KNIME. Now, if you want to follow up with any more KNIME stuff, if you're interested in the KNIME software, these are just a few links. You're also welcome to reach out to me or talk to me about it. And with that, I'll open up to any final questions, and I'll leave this QR code up here that goes to my LinkedIn. And if you'd like to email me any questions, that's okay too. All right.
Thank you, Corey. Yeah, that was very good. So, yeah, so I think we have one more speaker, Logan Chung. Yeah, so let's just take like 2 minutes or stretching a little bit while Logan gets set up. So, yeah. Okay, you're welcome. Yes, yes. You should be getting an email from Ron. Yeah, there's an email from Bill? From Bill, and then from there, I think we responded. Is it the website that I need to go into? No, you should have, Ron responded to this email with the URL for joining the Zoom.
Oh, really?
Yeah. Yeah, you should be in there because he sent it, if you refresh.
Is it part of the, the calendar invite?
No, it's the email from Bill.
Email from Bill?
Yeah, this
Okay.
afternoon when Bill sent out an email.
No, this is it.
Yeah, if you look at that thread, that there should be Ron should be responding back with the URL. Yeah, I don't know why you're not doing it.
Yeah. I don't have the URL.
Yeah, because I see it too.
I see Corey responded back.
Yes, yeah, and then I think Ron should be.
Nothing from Ron.
Yeah, Ron did. Send it to. At 5:56.
Okay, so I'm not looking for Ron. Oh, yeah, I didn't open it. I'm so sorry. So just join
Join
here.
that, and then don't turn on the video, don't turn on the audio. Because it's just for feeding into his.
Okay, so
yeah. Yeah, that's right. Don't join that. Join those, and just say continue. Yeah. And then from here you can share your screen. Okay. To share your slide.
Share my slide. Okay.
And just say share. Yep. And then he will pick it up. So yeah. And then you plug your plug that in. Yeah. One of them. Yeah. Then they just send it this way. It may take like a couple of seconds before. Yeah, that's how you do it.
Okay, good. And then I could just
It's good. And then you can use this for microphone, or there are also the lapel, this thing, these things too. If you want to use that, yeah. Okay. Yeah. Then it should be good.
Thank you so much. Logan. Yeah, thanks. Thanks. I really appreciate it.
Yeah, no worries.
Okay.
Sweet. Then we'll just make it right now.
Yes.
I have your speakers.
Oh, you made that. Okay. Is it a Google slide?
No, it's a PowerPoint.
Oh, no problem. Then you exit. Yeah, stop. No, that's fine. You can also go back to your. Yeah, you still need to share, but
Okay, share.
we're saying that your go back to your PowerPoint. Go back to your PowerPoint.
Okay, the PowerPoint.
Yeah, your local PowerPoint. This one to your not the share. Yeah, go there. Yeah, go to and then stop your slideshow. Stop your slideshow.
Okay.
And then basically, when you do slideshow, because you're running it in presenter mode,
Yes.
so the notes, the speaker notes, get shared to his screen too, and he doesn't want that. That's what he meant.
Oh, okay. So
Yeah.
you're gonna stop.
But you can see it too, right? Yeah. If you stop share, not the share, stop your slideshow. Yeah. We can do it again. I think.
So what I can do is just go back to Zoom and then share my desktop.
Yeah, you can do that. You can do the order, doesn't matter, but you want to go back to your PowerPoint. And now when you do a PowerPoint, you do the slideshow, right? Slideshow.
Yeah.
When you do a slideshow, you want to do what you call it?
When I do the slideshow.
Wait, because you are sharing. Okay. I
Okay, you
think.
want me to end the show?
Well,
You know what?
okay.
I don't have to do the slideshow. I can actually just do it so that I can
Yeah, you
present.
can just do like, but normally we like to do it slideshow. Because it's easy.
So-
But when you, do you need your speakers note?
No, I
So,
don't.
okay, in that case, you should be able to say slideshow, but without showing notes. I think there should be an option. Yeah, slideshow, go to your slideshow. Okay, that's blocking you. You want to move the zoom. There are two things right now. Yeah, you want to move radian, and then go to slideshow, the configuration. I think you should be able to say, because I haven't been using PowerPoint for a long time. You should be saying that not present view. Maybe like play. Is it like play from start? Can you just try play from start? Yeah. How come? So the idea, I think he doesn't want to see this at the bottom. Is what he doesn't want to record this.
Okay.
So maybe in that case you don't need this. Let me see. Looks like it's okay now.
It's
Looks
okay
like
now?
It's okay now. Yeah, he's not seeing. He just doesn't want to capture. Capture. I think.
The comments. Okay.
But otherwise too, yeah. I mean, let's see. I don't see it now, so let's see if he complains.
Yeah, let's see. Yeah.
I guess Ron's still talking. We'll give like a minute or two, and then we'll start. Yeah.
You might have an answer.
Yeah. Ready to start? Can everybody hear me? Yeah. Sorry, guys. I know. We're getting a little late. I really appreciate you guys hanging out. So I'm going to start with a little story, and I'm going to let everybody filter in while I'm tell you about my story. I'm probably the worst or the least educated programmer here. I hate Python. I'm going to share with you right now. I hate Python. I know, right? It's terrible. I have an uneasy relationship with Python. I'm going to tell you, I had a run-in as a kid when I grew up in Korea on the rice field. And as it turns out, Pythons don't like it when you step on them on the rice field. It took 4 guys to convince the Python to let me go. So, and the next time I ran into a Python was when I went to college. And oddly enough, they ran out of dorm rooms. And they said, hey, you have some certified off-campus places you could stay at. And one of them turned out to be a fraternity house. So I said, oh, fantastic. I'll take that. And I go in, and my roommate there happens to just have bought a Python. And he had a small Python on his desk. And I thought, oh, okay, that's small. We could deal with that. And he really loved it. I mean, he gave it all kinds of names, the whole 9 yards. Towards the end of 6 months that I stayed there with him, it's just uneasy. You know what I mean? Like, some people love Pythons, some people don't. When you sleep with one, it's kind of weird. So it's a little uneasy. So one day he goes to feed the Python, but this time it's grown. And he used to feed it crickets, now he's feeding mice. And all of a sudden the Python decides, well, you know what? I don't like that mice you're feeding me. I'm going to hold on to your wrist. So it bit him on the wrist. He couldn't convince the Python to release. So I am the guy in the car driving him to the emergency room with a Python wrapped around his arm. He didn't call it nice names. There was no pet names at that time. So that's the second time. And the last time I came across Python was I signed up for this NVIDIA class at the GTC event. And there's a deep learning foundation. And I thought, oh, how hard could it be? It's a foundational class. And one of the guys at my work kind of looked at me and go, Logan, you hate programming. And I said to him, yeah. He says, oh, you're going to run into Python. I said, yeah, I dealt with it before. I'm okay. So on the airplane, I figured out, well, that's not a Python he was talking about. So I started reading up on YouTube. I did a lot of YouTube video before I got into that class. And luckily, at the end of the class, my model turned out 92.1%. 92% was a passing grade. Thank God. So that's just a short story. So everybody's in here now. I think I want to show you. I know you guys spend a lot of time in programming whole 9 yards, and you put that out there for inferential application. You spend a lot of time, energy, and effort. When it goes into inferential side, that's where I get involved, because there's something called latency. And that's when they call me in and said, Logan, we've accounted for a lot of different application time, the model latency, the whole 9 yards, but it's still not working. We're still not in that timeline where we need to have this executed in time. As it turns out, 80% of the models fail in the execution side, in the inference side. So this is where I get pulled in. And the reason is this. The recent advent of H100s into GB200s, the compute powers are so increasing so much that our data centers, most of the data centers that was designed 5 years ago were designed with 10 kilowatt per rack.
think about it, 10 kilowatt per rack. The new GB200 is 120 kilowatt per rack. That means there's a lot of room you need to kind of space apart. Either that or go into a different data center. It also needs water. A lot of data centers don't have water because exactly for the fact that you don't want water with computers. So in order to build a new data center, it takes at least 3 years. That's if the ComEd or the power company gives you a block of power. So as you can imagine, there's a little bit of a challenge when you try to put that compute power at the edge. And they go, okay, maybe it doesn't belong at the plant, or maybe it doesn't belong at the airport. You need to go somewhere else where it has that power and cooling. That's why I get involved. So the cooling density, redundancy for operations when something fails, let's say your airport goes out, has a blizzard, ComEd, substation stops working, all of a sudden you need somewhere else to run that workload. That's what I get involved too. So, and also nowadays with manufacturing plants, they have robots. The robots used to be deterministic, no longer. They now have their own LiDAR and their own models that they will adhere to, and they need firepower at the plant. So the plant is constantly bombarded with competing power and cooling. So you're definitely going to run out of power at the plant if you're going to do a lot of automation. So we'll talk a little bit about that. And what we found with a lot of the workloads, the storage needs to be parallelized. It's not traditional storage, doesn't work anymore. So those are some of the things that why I get pulled into projects, and I'm here talking to you. Not that I hate Python. Okay? So here we go. Some of my customers, let's talk about latency because it's time. Some of my customers deal in nanoseconds. They're actually talking about picoseconds today. The trading company that I work with, Matching Engines, if you lose by about 20 to 50 nanosecond, you lost that trade. Somebody else just went ahead of you in the queue. This is not something earth-shattering. I mean, it's published. You know, I'm going to guess a lot of folks, you guys know this. It's an all-out war. Who's going to get there first? All right, and these guys are running algorithms. They're not running AI today, but they're going to. It's going to come behind it. So all the Monte Carlo algorithms are going to be assisted with AI. And there's now a lot of places where this matching engine sits that has the power and the cooling today. So I get involved. And believe it or not, the latency to cross from Chicago to London is 25 milliseconds now. And it's a shortwave radio that bounces off the stratosphere and comes down. And the quants place 10 trades, and out of 10 trades, 8 make it. 2 of them doesn't. Yeah? So that's type of latency that, and I'll share with you what happens where I could help inside this environment. And the next one is PLC. When you talk to like FPGA, PLC programmers, those guys are a whole other realm, and they tend to ask you, hey, if you're less than 1 millisecond, we're done. Don't talk to me. I don't want to put baggage handling thing out somewhere else. I got to be here at the airport. I've dealt with that too. So let's talk about that a little bit. So when we talk about TSAs matching people and profiling people and matching, that only requires maybe 2 to 3 seconds. However, when a person's moving from one terminal to another and you want to track that interested person, that takes real-time tracking. And that is going to take about 16 milliseconds. If you're off by 60 milliseconds, then you've lost kind of the trajectory of that person's movement. So that when you guys are programming, matching the whole 9 yards, this, in real time, this is where you want to be within when you guys deploy on the inferential side. So that's what we actually went through. Now on the latency, on the top section for the training companies, what we found was that the wireless and the laser was not as reliable. What we worked with them was on hollow core fiber. I'm going to guess a lot of you guys have heard of hollow core fiber. I don't know. Okay? No? Maybe not. All right. So quick description. Usually, your inferential engine sits here on this side. Manufacturing plant, airport, the whole 9 yards. And the data goes straight into the cloud. What's happening now is this edge site is running out of power and cooling. So now they're forced to come into a data center like ours, where they have to now place it. When that happens, you can guess the latency is going to become a big factor. And your model is going to fail if it doesn't adhere to that. And you're not looking for the latency, you're looking for the tolerance of latency. Many applications, whether it's external or internal, you're going to look at and go, yeah, okay, I could deal with 2 seconds, 3 seconds, but it's the tolerance, what you're missing, okay? All right. So, give you an idea. From downtown, where Cermak sits, where all the internet, a lot of the internet goes through, to O'Hare Airport is 20 miles, all right? You kind of do the math up there. 1 mile is 16 microseconds round trip. The best one over there is where it's labeled 13. That's 8 miles. We have a lot of data centers in Elk Grove Village, and Equinix is one of them. But that's where you want to place things. If you're thinking 16 millisecond is too long for your tolerance of movement inside the airport. So what they've chosen to do, they will place a workload inside Elk Grove Village, and they'll place another workload down here for resiliency. So that it's in a different substation. All right. So, by the way, the refractive index for air is 1, and for glass is 1.5. As soon as you move from air into hollow core fiber into a laser or a glass, silicon glass, you're going to slow down by 1/3. So as you can imagine, you want to keep it in air. Hollow core fiber is the best if you're thinking about literally microseconds. Okay? All right. So here, I'm going to share with you some of the trends on the data. And I promise, I think maybe I got, this is my last slide. So you guys are good for the night. So you guys are working hard on a lot of these trends that are on top. I see a lot of data lakehouses that are being created now. 50 to 100 petabytes, by the way. 50 to 100 petabytes in S3 bucket represents $2.6 million a month. It's quite a bit of money. So anyway, when you guys are doing this, what we have some, I have some private conversations with government contract people that are that has been in the AI industry for a long time, and their biggest worry is not the innovation that's occurring. Their biggest worry is the data protection, because what they say is if you corrupt the data, the model, there's no way the model is going to raise their hand and go, hey, you know what, I learned something terrible that I'm going to share with you. It never says that. You're going to find out in a real use case, like Google does, right? They're going to find out what happens, yeah? So what this agency said to me was, we've been in the business from the 60s. Right now, going forward, is a data security. And what I work a lot with is lowering the cost of data, 100 petabytes, maybe like in MinIO. Literally, you save tens of millions of dollars a year if you just put it in MinIO with cheap servers. And then you will turn on immutability, and you'll do bidirectional scanning, because then the layers of data will be protected. And every 6 months, you'll do an extraction and then recovery test to make sure nothing gets crypto locked. So that's how we kind of recommend with our customers with such a big set of data. There's not a lot of things you could do. There are other tools. I'm sure there's a lot of DLPs and kind of tagging the data and looking for the heuristics. But literally, I've seen this as a very simple way to protect the data on such a large scale. I think that's about it, guys. Appreciate any questions? Please, no questions about Python, but any other questions about infrastructure? All right. Oh, okay. Oh, yeah. I'm sorry. Yes, please.
Sorry, I don't know if you would have the answer to this question. But,
yes.
When you were mentioning the hollow fiber cables, does Equinix build its own fiber optic networks, or do they connect to pre-existing ones?
We do both.
Okay.
We do both. So, go, please.
Oh, I can't hear the microphone.
Oh, yeah.
Yeah.
So,
Is the microphone on?
hello.
Yeah.
Go ahead.
Sorry about that. No, it was just asking whether Equinix builds its own fiber optic networks, or do they plug into pre-existing ones from their data centers too?
Yeah. So yeah, we also actually provide private ducts so that the hollow core fiber runs a different path, and it's more of a direct path, as well as very private, so it protects the data. Okay.
Thank you, sir, for giving us this overview. So this reminds me of this book called Lights Out by Ted Koppel, which is a very interesting one when if the grid goes down, how things will work. So my question was that, you have some very crucial infrastructure that you're working on. And let's say, for example, an entity like an airport, how do they make their decisions and what criteria do they use when selecting data centers?
That's a fantastic question. It's really a function today for GB, let's say, first of all, the Grace Blackwell 200 runs 30 times faster than any other system. Absolutely. So you're going to bet they're going to use it. And few select companies are actually testing with it. We're testing with it in Silicon Valley. And so there's very few locations in Elk Grove Village today, right by O'Hare, that can accommodate 120 kilowatt and the cooling. That's how they choose it. And they're not going to go far from the airport. They can't. It's literally, it's a matter of latency. Yeah, it's just a matter of physics, how fast the light can travel. So, okay. Yeah, sure.
Hi. My question is relating to the power source. So I think there's this recent news article where Microsoft, I think, paid, $100 million to this company that makes nuclear power centers. I think the company's name is Constellation Energy. So I just wanted to get your thoughts on that. Is that the way? Is that the way that the world is going to move towards nuclear power?
It's a fantastic question. We talk about this every day with my with our strategist about real estate. Excuse me. So you do realize that Microsoft went to 3 Mile Island. They just started up the plant number 1, right? To get their power. Yeah, SMR is definitely a real. The small nuclear reactors is a real thing, but unfortunately, we're kind of behind the times, and we, as a company, decided, well, we're not going to be in the energy generation transmission business. However, we noticed we're keeping very close track of China. China has the first one, and they just conducted pull the plug test, and nothing went boom. So we're okay, and the small nuclear reactor actually did perform well. So for United States, where they say we're about 6 years out, 2030 will be the first one that you'll see come online. In the meantime, there's a lot of other things like the geothermal out in Utah. There's fusion. There's, you name it. The hyperscalers are going everywhere to find that source. Us ourselves, when we go to ComEd and say, hey, we want a block of, I don't know, 100 megawatt, because we got maybe 100 customers in Chicago area, ComEd kind of looks at us and go, you're out of your mind. We're going to charge you so much. So we are now going out to where the Argonne National Laboratory is. We're going out to where the kind of the Indiana universities are. So that's where the kind of future, because we can't, there's no power blocks in the metro areas that's going to be able to accommodate the oncoming shipping. Now the shipping is delayed for GB200. I think in the middle of next year is when the things are going to flow. But even then, like when we talk about power blocks, we're talking about 10, 20, 30, 40, 50 power blocks at a time. And a customer comes to us and says, yeah, we want, the smallest block we want is 1 megawatt. We have plans for 100 megawatt. It's literally impossible task for us to go to ComEd. ComEd will look at us like, okay, you guys are nuts. We don't have that. So absolutely, your question is very relevant about power generation. And everybody's kind of like caught on their heels today. Yeah, please. I'll get to you guys.
Yeah, hi, thank you for the session. Now, since global warming and the energy which is being used at the data center keeps on growing at a exponential rate because we are putting in more and more data center. So as an industry, we still have chip manufacturers beefing up with more power hungry chips, not more efficient chips, but basically more beefier and more power hungry chips in general. So how do you reconcile with this fact that there are measures in place which is all across the world to combat this global warming, because most of the energy which is being generated is coal-based or fossil fuel-based. And on the other hand, we keep on adding more and more power-hungry data centers across the world to fill the need of the digital expansion, AI, and whatnot. So how, as an industry, do you think we should move forward so that we reach a point where we are not actually going across where our energy generation for the clean sources are not actually matching up with the new data centers that keep coming up online?
Infrastructure anywhere within your facilities.
Using what infrastructure?
ARM.
Can you speak?
I asked if Equinix is currently using ARM chip infrastructure, which is supposedly more efficient, right?
Yeah. So the sustainability is an interesting thing. I'm going to tell you, because I'm on camera here, what the nice thing to say is we have carbon offsets. So you can't build a data center. We have over 260 data centers in 70 cities. When you have a data center at a city, you can't think that you're going to do this with solar power. You know what I mean? Renewable. It's ridiculous. No company is going to come to you and say, yeah, we're doing it, right? So what we do is we buy carbon offset. And we are, 95%. We say we're 95%. We're trying to get to 100%. And as recently we say, we actually heated up Paris Olympics pool. Fantastic. So that's kind of the answer for you. Off the record, absolutely, you're absolutely correct. And as a technologist, I'm looking for not the silicon next generation. I'm looking for carbon CPUs that takes a lot less energy. And you may have a whole generational industry shift that could actually keep going on the Moore's law on the GPU side. So that's it. Now ARMs, we do use ARM, and we're testing with it, and we don't want to fall behind with our competitors. So for sure we are, and I would encourage you to kind of, ARM is one of the, as a company, I think it's a fantastic company, by the way. So, okay.
I have a question about, have you developed data centers designed for multi-data center model training or inference?
Yes, short answer today is yes. As a matter of fact, our Secaucus campus and some of our metro areas, we intentionally built a data center within 7 nanoseconds of each other so that you can actually have multiple data centers as different availability zones, if you will, so they can have active type of training that could go on. And for resiliency as well. You can imagine, there's just so much physics you could pull away from the hollow core fiber to kind of set up that system. So what we did was we built data centers that are next to each other, very close to each other, literally across the street in some cases. And when you look at the dark fiber and you do the trace, a lot of them, we try to get to like the nanosecond range, anywhere from 7 to 30 nanoseconds.
What kind of challenges have you faced with this kind of thing? What kind of challenges?
So the challenge of doing this type of infrastructure build is the fact that only 2 years ago, H100 was out and the market started going crazy. And who knew that changing the pedagogy, transformers would actually change the industry, right? So a lot of the data centers don't have that type of power and cooling today. That's the big challenge. And when we go to get our generators, get our cooling exchangers, the whole 9 yards, that supply chain today, literally 3 years out. 3 years out. If somebody says to you, yeah, I could get you that power today, you better check on that and go, where is it exactly? Because that's the biggest challenge, is building a data center and having that. And the customers don't want to sign that GB200 rack unless they know where it's going to be stood up. It's millions of dollars investment without knowing where it's going to go. Please. I'm sorry, I know I haven't been on this side of the room. Thank you. Here you go.
Yeah, no problem. So another question is, you're talking about improving inferential performance. So I'm just wondering, with like alternative architectures like Grok LPUs, like, are you seeing a little bit of demand for that, since they're meant to be like, at least like, I think, 1/10 of the power consumption and like 20 times faster than your traditional like NVIDIA GPU?
Yeah, that's a very interesting question. There's a reason why NVIDIA is the powerhouse and they own 80% of the market. It's that CUDA. And as much as we like AMD and other providers, it's just market dictates it. Customers just don't come to us and go, and it's very literally 80%, 20% divide in our data center. Absolutely. We would love to see other infrastructure that takes less power consumption, for sure. But unfortunately, that's not how the developers are and how the APIs and all the codes are optimized for. You know what I mean? So we're kind of tied. Yeah. Thanks. Oh, please.
I'll make a comment, actually. So we've been talking about the power consumption from the hardware perspective, right? The real problem is we have software that uses too much of GPU. Isn't that true, right? So it's consuming billions, now trillions, and then I don't know where it's headed, right? So there's definitely a limit on how much hardware you can use. And the inference problems and all that stuff will come in. So we need to come up with smaller, more efficient models. So there's a software problem to this as much as the hardware is taking a lot of energy, right? So we need to improve on the models. And there's a very interesting discussion on the Turing Institute. So one of the professors there presenting, I'll have to find it, I can't just refer to it, but so the interesting point that this professor was making was, yes, we have LLMs that do a lot of things, but it's sort of throwing a lot of data at a system which is not very efficient. So we need to improve on these models and get the efficiency of these models. And then we can infer, we can do everything much more efficiently. Can we run them on our little phones here? How much hardware improvement can we make? There's a limitation. And literally these days, a lot of coders have lost the art of optimizations, right? So, okay, we have 32 gigs of memory on my laptop to work with. We don't have to be that efficient. No, you have to be efficient to utilize 32 gigs on your laptop so you can do a lot more stuff than we used to do, right? So there's a software aspect to this as well.
Thank you for that. And that just confirms there's smarter people in this room than me. So fantastic. Thank you. All right, any other? And I think we're done for the night. Thanks, guys. Really appreciate it. Okay.
Thank you, Logan, and thank you everyone for attending tonight's meetup. And normally, too, we would like to, have you all socialize in here. But then David just informed me from Microsoft, and he said he needs to meet someone, so he cannot stay for too long. So I kindly ask you to start. You don't have to rush out, but just be cognizant about that and try to pack up sooner. But then I'm kind of thinking, if you like, we can still go outside of this. This floor. That's right, yeah. The lobby and also the downstairs, that area is very nice too. So we can still, yeah, that's right. If anybody wants to hang out, we can consider going to maybe Elephant and Castle if you want. So yeah, so let us know. But want to thank you again, everybody, to Dean and then to Corey and also to Logan for tonight's presentations, and then to Ron for doing all this stuff, or AI Alliance and Microsoft sponsoring and all the NIME and Equinix too. So thank you, and to Nitin for helping with all the food. Thank you so much, and Nick, who already left, and Nick had to go too. So for both of them. So thank you again to everybody. If you want to help, please let us know. And I think Narendra, I don't know if Narendra is still here, but maybe he left too. So he wanted to help. So, but if anybody wants to help, please come forward and let me know. So thank you again, and see you again next month. It will be October 17th and at JP Morgan Chase Bank in the heart of the loop. So yeah, I'll see you again next month. Thank you.
Do visit us at the Chase Tower. It's going to be a good.
Yeah, it'll be really good.
Fill it up, okay?
That's right. Thank you. Okay, bye. But still hang out with us if you want. So downstairs in the lobby.